Hi, everyone. Looks like everybody's got a seat now, so we're going to kick off. Welcome to day one of reInvent. Super excited to see how many of you have joined us for today's session. It's all about accelerating your ML journey with Amazon SageMaker low-code tools. I'm Clara O'Brien Rajkumar. I'm a product manager on the SageMaker team here at AWS.
Hi everyone, my name is Vadim Amelchenko. I am a senior solutions architect in special sector focusing on artificial intelligence and machine learning services. Looks like we have a full house here today. That's awesome. I guess people don't like writing a lot of code nowadays, right? How can we help, Claire?
So just before we get into today's session, wanted to get a quick sense of who we have in the audience today. So do you mind just putting up your hand if you consider yourselves, fairly new to machine learning or still a beginner with machine learning? Okay. And who here considers themselves, more of an intermediate or maybe advanced in their machine learning skills? Okay, great. So we've got a pretty good mix here, which is perfect because we're going to be talking a lot today about how these low-code tools are appropriate for you, whether you're new to machine learning or whether you're an advanced ML practitioner. So today's session, we are going to start by covering an explanation of low-code machine learning, why you should use low-code machine learning and how it helps you move faster. Secondly, we're going to be walking through each of SageMaker's low-code ML tools, and Vadim will be giving you a demo of each of these tools. We want you to walk out of here with an understanding of how low-code ML helps you move faster, with an understanding about how you can use these tools in your experimentation workflows as well as in your production workflows, and with a familiarity of what these interfaces look like so you feel confident that you can get started quickly. Before I start talking about low-code ML, just going to set the stage by talking about the typical ML workflow. We've got 4 steps here, and we typically start by preparing your data. We all know that high-quality data preparation is critical to high-quality model performance. And you'll often hear it said around data scientists can spend 60 to 80% of their time actually on preparing data. Once you've gotten your data in a good place, you go to building your model. So you're selecting your algorithm or you're scripting your algorithm, and then you're training and tuning your model. You're experimenting with different features, different algorithms, different parameters, until you're happy with your model performance and you're ready to deploy it to production. And when you deploy your model, you obviously want to plan for hosting that model and monitoring that model. I've kind of built it up here as you deploy your model, your ML project is done, everything's great. But we all know data coming in from the real world never looks exactly like the data that you trained your model on. So your ML team is going to need to be working on retraining, retuning that model. You're going to be wanting to deploy new versions of that model so that your predictions can remain accurate. And I want to explicitly talk about 3 challenges that customers have with the ML workflow. 1, it requires deep expertise, obviously in data science and ML, but it also requires expertise in provisioning the infrastructure that you actually need to execute that ML workflow. Secondly, all of the experimentation and iteration is time-consuming and resource-intensive. I talked about the experimenting with different features, experimenting with different algorithms, tweaking the different parameters. This all has a high time cost. And then lastly, and this actually might be the challenge that we hear the most from customers, is that there is really a bottleneck in their organization around the amount of ML resources that they have available. So in their organization, they have all this demand for ML projects. They want to use ML more in their organization, but they only have so many data scientists and ML practitioners. And this is where low-code machine learning comes in. So the whole goal of low-code machine learning is to make your ML practitioners more productive while preserving the flexibility and the visibility into the solutions that they are building. So how do we accelerate your ML workflow? We do so by removing the need to write boilerplate code, by automating the experimentation, and by offering pre-built capabilities that you can deploy quickly. All of the solutions that I'll talk about today are open box and customizable. So you can go under the hood, you can understand what automation is taking place, and you can tweak and customize those solutions as you want. These solutions all give you the ability to pivot and the flexibility to use a pro-code approach when you want, and they can all be used in experimentation as well as in production workflows, which makes them appropriate for, as I've said, those new to machine learning as well as those advanced with machine learning. So we have 3 low-code tools within SageMaker. These all live within SageMaker Studio today. We have Data Wrangler for low-code data preparation. We have Autopilot for building, training, tuning, and deploying models. And lastly, we have SageMaker JumpStart. JumpStart is an ML hub where you can come and discover state-of-the-art pre-trained models and solutions to help you quickly deploy those models. I'll start by talking about Data Wrangler. So Data Wrangler is a low-code tool for preparing data for ML. You come to Data Wrangler and you can import tabular data from several different data sources. We have internal data sources, S3, Athena, Redshift, as well as external data sources. We support Snowflake, we support Databricks. You should actually keep your ears open at some of the keynotes later this week for some exciting announcements around the sources within Data Wrangler. And once you've imported your data into Data Wrangler, you can use our visual point-and-click UI to explore your data and to transform your data. Once you've explored and transformed your data using our UI in a very visual approach to data preparation, you can then move on to building your model by launching an Autopilot experiment from Data Wrangler, or you can go and move that data preparation workflow that you built in this visual UI and use it as a SageMaker processing job so that you can bring that data preparation to training and inference pipelines. So a little more about how we accelerate exploratory data analysis within Data Wrangler. We have pre-configured visualizations that you can generate within a few clicks so that you can understand the distribution of your data and you can get insights into your data. We also have several ML-powered analyses that you can also generate in a few clicks. You can use these to do things like understand feature importance or detect bias in your data or understand any other high important issues with your data, such as what you see on the screen here. We even have this really cool feature. We call it Quick Model, and this allows you to use a pre-trained XGBoost model to quickly understand how the quality of a model trained on the data preparation that you have done, so on the features that you have built so far within Data Wrangler. So customers can kind of use this iteratively within their data preparation process. Once you've understood your data and you know what steps you want to take to transform your data, you can do so using our 300+ point-and-click transformations. These are all ML-specific transformations. So you can think about one-hot encoding, you can think about dimensionality reduction using PCA. But we also, as I've said, it's very important for customers that they have the flexibility to use code when they want. So we do have a custom code editor where you can come in, you can author your own complex transformations, your own custom transformations as you want. And we actually even have a library of code snippets that you can then tweak and edit to make faster custom transformations. And once you've prepared your data and you're ready to move to the next stage of the ML workflow, I mentioned that you can launch an Autopilot experiment from Data Wrangler to build a model based on your data, but I'll tell you a little bit more about that in the Autopilot section. What I'll talk about here is how you can process your data at scale from Data Wrangler. So you can launch a SageMaker processing job from Data Wrangler using the Data Wrangler UI, or you can export all of the orchestration code to do so either in a notebook or a Python file, and you can use those within SageMaker pipelines or whatever other pipeline construct you may want to use for your training and inference workflows. We natively support exporting data to SageMaker Feature Store as well as Amazon S3. So here is a slide just wrapping together everything we talked about Data Wrangler. So on the left-hand side, we've got all of the sources that we import data from, and on the right-hand side, we have all of the sources that you can export your data to in Data Wrangler. And in the center, we have Data Wrangler's core competency. So we have the Data Wrangler UI, where you can take a completely low-code visual approach to experimenting with your data, to iterating on your data preparation. And what's really happening under the hood is that Data Wrangler is creating two artifacts. One, it's creating a Data Wrangler recipe, a .flow file. This has all of the code based on the transformations that you have added to your data preparation workflow. It is also creating all of the orchestration code to run a processing job using that Data Wrangler recipe file. This is in the form of a notebook. You can obviously launch a processing job from the Data Wrangler UI, or you can take both of these artifacts, you can look at the code of them, you can understand them, you can tweak them, and then you can bring them into any type of pipeline you want. So I will be coming back to this slide a couple times throughout the presentation so that you can understand where these low-code tools fit within the different ML workflows and how they work together. So just going to take a moment to walk you through this right now. So on the top, we have the development workflow or the experimentation workflow, typically owned by the data scientist. They're working on a sample of the data, and they're really experimenting and iterating. They're going all the way from just going from a raw data set, exploring that, and then building, training, tuning, and coming up with a model that they want to deploy to production. They're then handing it over to ML engineers who are retraining that model, preparing it for production, and then they're sending it into production. And so on the bottom here, we have our predictions workflow. We have the predictions requests coming in from the real world. Of course, we need to do all the same exact feature engineering on those predictions requests as we did in the training workflow and in the development workflow in order for the model to understand the data and ultimately give us our predictions back. And so that's where Data Wrangler fits in really nicely. Up in the development flow, you have the Data Wrangler UI. You're benefiting from all of the interactive, experimental, visual preparation that you can do within the UI. And then in the training and the predictions workflow, when all you really want to do is replicate exactly what you did in your development workflow, you can just use a Data Wrangler processing job in those two workflows. So with that, I'll hand it over to Vadim, and Vadim will be doing a demo of Data Wrangler.
Claire, thank you, Claire. So this is what Data Wrangler user interface looks like. You can access it from SageMaker Studio UI. And what you see on the screen is data transformation workflow, which I pre-created ahead of time. In this case, I used a sample data set trying to predict insurance claims fraud. The data set comes from two data sources. So if I was to zoom in here, this is where my workflow begins. Customers table is in Athena database, and claims happen to be in flat files and CSV files in S3. And so you start designing any Data Wrangler flow by importing your data sources. And so you can do that by going to import, clicking create connection. And these are some of the data sources that we support as of today. But as Claire said, stay tuned for the announcements. And so once I imported them, the first two transformations that you see here are created for me automatically. Data Wrangler auto-detects the types of columns in my data, but I have a choice to adjust that if I choose to do so. I visualized a couple of these data sets right away, but actually the real power comes when I join them together. And so what you see here as next transformation is joining them. And I'm joining them on the same column that exists in both data sets, policy ID. And once I joined them, that's when I actually visualized it again and created data quality and insights reports, one of those exploratory data analysis that Claire mentioned that's available to you in Data Wrangler. As you can see, let me see if I can zoom in here. First few things that come up in data quality and insights report are the basic statistics about your data set, what kind of features you have, how many rows, do you have any missing values, If there are any high priority warnings, they're going to surface right here. One example would be maybe you have target leakage and you'll see it right here and right away. Duplicate rows, if there are any. Anomalous samples. You get the breakdown of your target column. In this case, we're trying to predict if it's a fraudulent or non-fraudulent claim. And I can see that my data set is highly imbalanced. 97% of my entries are non-fraudulent. The algorithm builds a quick model and confusion matrix, and then you get to see actually even feature importance, which columns contribute the most to the model that was built using the quick build functionality. And there is a lot more here. I'm not going to go through the entire report, but you kind of get the idea. After I visualized my data, this is when, and actually before doing transformations, I decided that I want to save the joined data set before doing anything else. Maybe I want to use this joined data set later in another workflow or further downstream. So I saved it into S3 as a destination. And next, I'm dialing in transformations. The actual transformations to the data that I want to have because of the algorithm that I choose to train the model. And the first one is dealing with categorical data. So I want to one-hot encode my categorical values. You can see here on the right-hand side, there is a number of columns, and I'm creating one-hot encoding for them. If I wanted to do more transformations right here, I would click on the plus sign and go add transform. And Claire mentioned there's almost 300 different transforms that you have access to. These are just categories. If I drill into these categories, there is a number of ways, number of functions, like if I wanted to handle missing values, there is a way to impute them, fill missing, add indicators of drop missing, and things like that. So that's the transformations. You dial them here. And then once you created your recipe for data transformations, and you're ready to save the data, the final data, in my case, I want to split my data set into training and holdout. So I have a splitting block, and then I'm saving the training data into destination S3, and I'm saving the holdout data set again to destination S3. Finally, I realized while doing transformations that some of the features might be useful for other workloads or other data scientists, and I want to not just store them in S3, but maybe preserve them in feature store so they can be accessed by others. And so there's another transformation you can see here where I'm sending my features into data store, a feature store. So this is the flow. Now, to execute it, as Claire mentioned, this is a recipe, and now we can execute it. And one way to run it is by clicking Create a Job right here in the UI. I give it a name. I can configure this job to run on schedule. I can choose the hardware requirements for this job, in this case, M5, 4XL extra large, 2 instances. And if I click Create, it will actually execute a processing job, which will run. Alternatively, again, as we mentioned earlier, you can use this recipe further in other applications or pipelines or scheduled jobs, and you do that by exporting this workflow as code. And the choices here are, if I go to export, you can export it as a Jupyter notebook, you can export it as a step in the SageMaker pipeline, you can export it as a plain Python code that you can run elsewhere. So if I, for example, choose a notebook, it will create the orchestration code. This code is automatically generated by Data Wrangler. You can see the commands to grab your data from S3, from Athena, upload the recipe to S3, define the processing job, and actually right here is where it's creating a processing job. It defines SageMaker processor, and here it runs it. This is what we mean by when we say these are open box type of tools. It's not something that's happening behind the scenes and you don't know what. You get to see the code which gets executed, and you can actually even alter it if you have to. So this is it. This is the example of Data Wrangler workflow creation from sources to destinations, running it as a job from a console or exporting it as code. Back to you, Claire.
Great. So I am going to jump back in, and I'm going to talk about SageMaker Autopilot. So as I said before, Autopilot is a low-code tool for building, training, tuning, and deploying models. So you can come to Autopilot with your data set, specify your target column, and launch an Autopilot experiment. Autopilot will do your data pre-processing, it'll do your algorithm selection, it will run multiple trials with different models and parameter combinations, and finally, it'll give you a model leaderboard, where there is a model that it's built from each of the trials that it has run. As part of that model leaderboard, you have all of the model artifacts and assets so that you can explore and understand the model that Autopilot built for you. You can then deploy that model to a SageMaker endpoint or to any endpoint that you want. I really want to take a moment to talk about how Autopilot accelerates the model development phase of the ML workflow. It does this by running diverse trials in parallel. So in a pro-code approach, we see data scientists scripting model and parameter combinations one after another. So they're doing all of this trial building sequentially. With Autopilot, it automates it so that it executes all of these trials in parallel, saving you all of that time that you would have otherwise spent doing trials one after another. But in the next two slides, I'm going to talk to you about the control that you have over Autopilot experiments and the visibility that you have into the models built by Autopilot, because we know that this is very important for folks in their ML journey. So how can you customize your AutoML journey within Autopilot? Within Autopilot, you can choose which features are used in your Autopilot experiment. You can specify your data split or upload your own data validation set. We also have an integration with SageMaker Data Wrangler and Autopilot. So you can do all of your data preparation and feature engineering in Data Wrangler and then launch your Autopilot experiment. Autopilot will still do data pre-processing, but it will do so on the features you have built in Data Wrangler. So this allows you to apply a lot of your subject matter expertise and your domain knowledge into that data, that feature engineering process before launching your Autopilot experiment. And then finally, you can choose the training mode within Autopilot. We have two training modes: Ensemble, powered by AutoGluon, and Hyperparameter Optimization, or HPO. We see comparable model performance across both of these training methods. However, we do see that for smaller data sets, ensemble training jobs complete significantly faster than HPO training jobs. So if you had a data set of about 1 megabyte, an ensemble training job would finish in approximately 15 minutes, whereas an HPO training job would finish in about 120 minutes. So if you were to leave it to Autopilot, it would automatically use Ensemble for smaller data sets less than 100 megabytes and HPO for data sets larger than 100 megabytes. There's also a slight difference. Ensemble has 8 algorithms that it uses across its trials, whereas HPO has 3. So there is a bit of a difference in the algorithm diversity used in the trials across these different training modes. So now, about the visibility that you have into the models built by SageMaker Autopilot. So SageMaker Autopilot, it provides you this model leaderboard where it ranks the models by objective metrics, and in the case of Ensemble, it also ranks it by a combination of objective metric and inference latency, because AutoGluon models tend to be very large. And as part of that model leaderboard, you have several different model assets. This includes your data and your training and validation data sets. It includes your feature engineering code, and it includes your deployable model. In this deployable model, you can see the algorithms that are used in the model, as well as the set of parameters. There is also a model insights report, so you can understand the performance of your model against common performance metrics. And then finally, you also have this data exploration report. This gives you a lot of insights into your data and the data quality. It's actually very, very similar to that data quality report that Vadim showed you within Data Wrangler. Once you've decided which model from Autopilot you want to deploy, you can deploy these to a SageMaker or non-SageMaker endpoint. You can do it for batch or real-time inference, and you can do so either in the Autopilot UI, or you can do so using the Autopilot APIs within the SageMaker SDK. If you have prepared your data in Data Wrangler and then launched an Autopilot experiment from Data Wrangler, your data flow from Data Wrangler will also be deployed as part of that inference endpoint. So again, bringing the subject matter expertise and domain area knowledge that you applied to your feature engineering to your inference workflow. So here we are back at this, this slide that I showed you earlier with the 3 ML workflows. What you can see here is that Autopilot really can do your end-to-end ML journey. You can come to it with a data set, specify your target column, and it can do everything from the data exploration, pre-processing, model building, to suggesting which model you should deploy into production. But what I really want to call out is how nicely Data Wrangler and Autopilot work together here. So we hear about this customization, this desire to make AutoML relevant to your use cases and a desire to apply your subject matter expertise to AutoML. And this is where Data Wrangler comes in. You do that in the data pre-processing and data preparation phase before launching your Autopilot experiment. So I will hand it over to Vadim to demo Autopilot.
Thank you, Claire. All right, we're back into SageMaker Studio UI. There are 3 ways you can run Autopilot. One is obviously through, like anything else in AWS, through API call. Another way is by, in SageMaker Studio, going to File, New, Create Autopilot ML Experiment. And it takes you to this dialog with about 4 screens where really all you have to do is hand it a data set and optionally set some additional parameters, and it's going to go. But what I would like to show right now is an ability to launch Autopilot from your Data Wrangler. As Claire mentioned, sometimes you will want to do your own feature engineering before handing it off to AutoML. And so right here, I have another sample use case where I used a hotels data set, attempting to build a model which will predict the likelihood of cancellation. And so I did a little bit of transformations here. I, again, split my data set into training and holdout. And so using training data right here, right now, I would like to click plus and go train a model. This takes me to a first screen where Data Wrangler tells me it's going to actually export the data and pre-stage it for Autopilot, which I'm going to agree to. And then once the data is exported and transformations have been applied, I'm back in the familiar Create Autopilot Experiment screen. The name of the Autopilot experiment has been pre-populated for me, but I can change it. The location of the data set is also pre-populated because Data Wrangler already exported my transformed data. I can allow it to split the data set into training validations because, as Claire mentioned, Autopilot will experiment on our behalf, meaning it'll have multiple pipelines, it'll build multiple models. And to evaluate each and every model, it needs to have a validation data set. I can bring my own validation data set if I want. I can influence the split ratio. By default, it's 80-20, but I can adjust that. On the next screen, the only other thing we need to tell Autopilot is what is our target column? What is it that we're predicting? Which field in our table? So is canceled is the field that I'm after. And you also have a chance to manually select or unselect some of the features, exclude some of the features that you maybe don't want to Autopilot to use. Next, I choose the ensembling or HPO training method. And finally, because we are launching Autopilot from Data Wrangler, we have this little selection here. Do we want to allow Data Wrangler transformations to be baked into the model, basically? And yes, we do. We can name our endpoint and maybe select that it's a binary classification, and I want to use F1 as objective metric. review, and click go. And this will actually kick off an autopilot training job. And as Claire mentioned, if it's ensembling, you can go grab a cup of coffee, come back, 10, 15 minutes, you're good to go. If it's HPO, go have lunch, come back in an hour or so. And this is what you'll see when you're back. Once the job has completed, in my case, I pre-executed it a few days ago. And as a result, Autopilot built 5 different models. And this is called model leaderboard. You can see the best performing model is at the top, and it's marked as best model. The objective metric is pretty close on all of them, but Autopilot also takes into consideration latency score. So the faster the model, the higher it gets ranked as well. The faster meaning during prediction time. If I click here on the right-hand side, view model details, it takes me to the screen for this best model, and I can see the feature importance. And in this case, we can see that looks like the likelihood of hotel room cancellation is heavily dependent on the country from where folks are making those reservations. You can see some of the hyperparameters that the Autopilot ended up choosing for this particular model. I can go and deploy the model from that same leaderboard. There is a deploy button right here on the right-hand side. Deploy the best model, and that takes me to the deployment screen. And there are 2 modes in which I can use this model right away. The first one is batch predictions. This is where I don't even have to deploy it. I can create a transformation job. The parameters for the job are pre-populated for me. The name is pre-populated. The model is pre-selected. I can choose the hardware, size of the hardware, number of instances, and all I have to do is point it to the location of my data set that I'm trying to generate predictions for in S3. And that will create a job. A few minutes later, I'll have it all transformed. Alternatively, I can deploy Autopilot as an endpoint and expose that endpoint to downstream applications to make RESTful API calls as records are coming in to make predictions on the fly. And notice how, because we allowed Data Wrangler workflow to be embedded into the model, we also have this right here confirmation that, yes, we want to include Data Wrangler's transformations that we apply to the training data. We want the same transformations to happen during predictions. And so let's say if I deployed the endpoint, how do I use it then? These few lines of code give you an idea how to actually make calls to the model that Autopilot created. A couple of lines of familiar to everyone, connecting to AWS service, defining the name of my endpoint, defining the payload. Notice it's same format as I had for the data set, CSV basically. It's unprocessed, which is okay because the Data Wrangler's steps will pre-process it during predictions. I'm encoding the line and I'm invoking the endpoint. And I get back, yes, this particular entry is very high likelihood of being canceled. That's how you use Autopilot, from training it all the way to inference. Back to you, Claire.
I am going to jump in for our last section to talk about SageMaker JumpStart. So SageMaker JumpStart, it's an ML hub for SageMaker customers. We have state-of-the-art pre-trained models, pre-built solutions to help you deploy those models quickly, and we have example notebooks that help you walk through common ML solutions. You can find SageMaker JumpStart content in SageMaker Studio, and now available in preview, so a very exciting launch within the SageMaker console. And then lastly, you can invoke SageMaker APIs JumpStart APIs via the SageMaker SDK. So pre-trained models within JumpStart. So there are many common use cases out there where you really don't need to build a model from scratch. And for many organizations, not building a model from scratch, using a pre-trained model helps them save a lot of time and ML resources. We're talking about that bottleneck in ML resources that we consistently hear from customers in their organizations. So JumpStart, we have 350 plus pre-trained models and algorithms. These models and algorithms do typically come from publicly available sources, but there are two advantages to using them via JumpStart. One is compatibility with SageMaker. So when we import these models from the publicly available sources, we package them with SageMaker training and inference scripts so that you can easily use them in the SageMaker ecosystem. The second advantage is security. So again, when we import these models from the publicly available sources, we do security checks and then we host them in our secure S3 bucket. So we hear from data scientists that this saves them a lot of time that they would otherwise spend importing and maintaining publicly available models in their own organizations. SageMaker solutions templates take it one step farther than our pre-trained models. So while you have these pre-trained models, you have the inference and training scripts with them, you still do need to set up all of the AWS components around the model to execute your ML workflow. These solution templates are CloudFormation-based templates, and so within a click, they set up all of the AWS components that you need to support your ML workflow. They're all flexible solutions, so you can switch out any one of the components you want. If you want to use a different algorithm, you can just go into the model notebook and you can edit it. They're very customizable. Lastly, we have these JumpStart example notebooks. So these example notebooks are end-to-end approaches to common ML problems. They are just Python code-based notebooks, and they're really an accelerator for when you want to take a very pro-code approach to a common ML problem, but you need some help or guidance on how to move faster. So in this slide, I want to just capture a little bit about how JumpStart it takes a bit of a different view of the ML workflow than Data Wrangler and Autopilot. So in Data Wrangler and Autopilot, we started with a data set, and then we prepared our data set, and then we built a model on our data set. So a very data-centric view of the ML workflow. JumpStart, however, starts at the other end of the ML workflow. It starts with the use case, works back from the use case to identify the model you want, and then you go and you prepare your data to fit that model that you want to use. And so that's where JumpStart and Data Wrangler actually work really nicely together. You get your pre-built model from JumpStart, and then you can go backwards. You can go into Data Wrangler, and you can very quickly do all of the feature engineering you need to get your data ready to use with that model. And then again, you can just use the Data Wrangler processing jobs in the training and inference workflows to replicate all of the feature engineering you did in development in those later pipelines. So I am going to take one moment just to quickly talk about one type of pre-trained model that we have within JumpStart. So this is pretty exciting, but foundation models are a newish emerging area of ML. They're used for a variety of different use cases with high accuracy, and they have these very kind of fascinating emergent properties. So people really want to tap into foundation models and figure out how they can use them. But the main challenge is that these models, they're huge, and they have billions of parameters. So they're just extremely expensive to train. And this makes them a great candidate for pre-trained models. You're an organization, you don't have the resource to build foundation models, or you don't have the resources to pay for training these models. There are pre-trained foundation models out there so that you can tap into this kind of newer ML development in ML. So excited to tell you that we have foundation models both available from publicly available sources as well as partner sources available within SageMaker Studio, and as I said before, now available within the SageMaker console. And you can launch these foundation models to inference with a single click. So I'm going to hand it over to Vadim to do a demo of JumpStart, and then he's actually going to hand it over to an exciting guest speaker that we have joining us for this presentation. So Ori Goshen, the CEO of AI314 Labs. AI314 Labs is a leading startup in the foundation models area. He's going to join us on stage. He's going to talk about their work in foundation models, and he's actually going to do a demo of one of his foundation models that you can now find in the SageMaker console. So,
thank you, Claire. So this, again, we are in SageMaker UI in JumpStart section. you can see that it really is a catalog of models and solutions and notebooks. You can browse it by machine learning task that you're working on, by data types, by framework types, type of model that you're looking to build, computer vision, text, tabular models, audio models, image classification, pretty much all the verticals of machine learning applications you can find here. Each and every model has a model card. You can see the source of the model, whether or not it's fine-tunable. So some of the models you will be able to deploy, well, all of the models you will be able to deploy as is by selecting configuration. Let me make it a little bigger. By selecting hardware configuration, name the endpoint, deploy it, and then pretty much the same code that I showed you to call Autopilot's trained model, same code will work calling these models. And some of them are fine-tunable, so you can actually bring your own data set and train the model on your own data. And once you trained it, or once you deployed actually the model, you get a screen where you can click a button to say make inferences, and it'll generate a code to do inferences for you. So let me give you an example. In this case, I'm using one of the foundation models, Stable Diffusion. It happens to be non-fine-tunable, but I can still deploy it as is, which I did. And once the endpoint is deployed, you can see that it says right here, the endpoint is in service. And I can click Open Notebook, which takes me to the sample code to run this model right here. This code has been auto-generated after I deployed the model, so I don't have to change anything at all. And it's pretty simple. Name of the endpoint, connecting to SageMaker, a simple function to help parse the response, because it's an image actually that comes back, and the function to display that image. And this is what I'm passing. I'm making a query to the Stable Diffusion model, and I'm saying, I draw me a cottage in an impressionist style, and this is what came back. So, speaking of foundation models, Claire mentioned that we are now exposing them as well in AWS console, right here in SageMaker console actually. You can see under JumpStart, foundation models are available here. And if I was to pick one, view a model, Alexa TM for instance, I can actually try it right here without even going through the motions of deploying it in SageMaker Studio. So on this note, I'm going to call Ori to show us the exciting models that AI21 Labs are working on.
Thanks, Vadim, and hi everyone. I'm very excited to be here. So in AI21, our mission is to change how people read and write, making both of these experiences AI first. If you think about it, nothing a lot has changed in reading and writing since the 80s, since we used to work with word processors. And nothing really changed in reading since Gutenberg's time in the 15th century. So our company is really on a mission to change both of these experiences. And so we develop our own large language models and that power our own applications, Wordtune and Wordtune Read. Wordtune is a writing companion that helps people actually to express their ideas and find the right words to what they're trying to say. And Wordtune Read is a reading assistant that helps people skim through long documents and digest them much faster. But we understood that if we really want to change how people read and write, text is everywhere. Almost every application has a reading and writing component. So we wanted to open our language models as a platform for other developers to build their text-based applications. And so around a year ago, we launched AI21 Studio, which is a developer platform that makes these larger language models available. We have a wide variety of models, And it's actually pretty funny that the smallest one is called Jurassic 1 Large. And we making it available with a very simple and easy to use APIs that anyone can work with, just with specifying in zero shot or few shot, just putting in a few examples, and the system will pick up the patterns and will generate coherent results. And the system, the platform is also customizable, so you can upload your data and make your custom models if you want to maximize performance or to leverage your own data. And this really opened unbelievable amount of use cases from so many industries and domains. Thinking about gaming until financial industry, it really runs all across the gamut. Take gaming, for example. We have companies that use our foundation models to generate characters in the worlds and basically interaction with virtual characters. And we have gaming companies that use these foundation models to generate better gaming scripts. And in the financial industry, we are seeing a huge demand for processing long reports, summarizing them, making them more accessible, and repurposing that content for different audiences. And in general, we see a lot of different enterprise use cases. Again, text is everywhere, so there's so many workflows to streamline, from creating product descriptions to generating T's and C's. There are so many possibilities. And so what's so unique and exciting about the Jurassic models? First, we designed our models to fit into industry standard hardware. So it's really optimized to run on the hardware. You get best performance. We made some architectural decisions on the width and depth ratio of the neural nets. One of the key decisions is how deep is your network? How many layers are you choosing to have your network? And one of our research showed that depending on the size of the network, there is a depth inefficiency area where you want to avoid. So we really incorporated these lessons when we designed the model that we trained. We also made sure this is robust, and the models are robust and are designed for safety. One of the latest research in the field by Percy Liang at Stanford showed that the Jurassic models are actually top listed as the safest models. And we created, when we trained the model, we trained it with a huge vocabulary, so we can capture more idioms and multi-word expressions like editor-in-chief and bang for the buck. So the models will understand that these are single lexical units, basically, so they can actually treat it that way. And finally, we are constantly releasing dedicated APIs for language-specific tasks. So a lot of work on top of the language models could be abstracted away. So when you get results from the language model, you need to prune it, you need to rank it. There's a lot of algorithmic work to do on top where we want to take it away and do it for the developers. So we have models that are specialized in rewriting or summarizing content and so on and so forth. So we actually recently just finished training our random model on the SageMaker platform. And I'm, as Vadim mentioned, I'm really excited to announce the Jurassic random model availability on SageMaker JumpStart in closed preview. And we're expecting more and more models coming soon. So let's make a quick demo.
Space, stop, go.
So this is the JumpStart console and playground that you can actually interact with our models. This is again the Jurassic 1 random model. You can simply specify a prompt, in this case summarizing a restaurant review. So you put in the restaurant name and the review and ask it to fill in the summary. And you'll basically see that the system generates a coherent summary. There are two examples here. And you can keep going and generate more and more of these summaries. So this is the first example, but you can also work with a notebook. This is where you get kind of an overview of how to use the notebook and then clone it into your SageMaker environment. And you have instructions here around how to create at the endpoint, how to prepare the input. In this particular case, we wanted to build a CV profile generator. So you put in just a few bullet points, and then the system generates a CV profile for you. So we gave a few examples, like role, business manager, and a few skills, and then profiles. We just gave a few of those. And you see here, this is the prompt. And this is the input example, right? A winning CV profile for a sales executive, incorporate the following features. And we'll let the system complete with the profile. And now it's basically going to give a few inference results. You can see here, I'm an organized and energetic sales executive with 6 years of selling experience, and so on and so forth. So you see, you can sample the system and get actually a wide set of generations. So thank you very much. That's it, and I'll hand it over to Claire. Thank you.
Thank you so much, Ori. Ori is in town all the way from Israel, so very grateful that he could join us here today. So just to wrap things up, quick reminder about low-code ML. We spoke through 3 tools today, all live within SageMaker, within SageMaker Studio. Talked about Data Wrangler for data preparation, Autopilot for model building, training, and tuning, and JumpStart for using pre-trained models and solutions for deploying those models. The whole goal of these low-code machine learning tools is to help you move faster with your ML workflows, and they're open and customizable, so they're really appropriate for both new and advanced ML practitioners. We have a bunch of sessions throughout the week going deeper on each of these low-code tools, so feel free if you want to check them out, take a picture of this, and you can go. Some of them are hands-on workshops, so a great way to get started with these tools. Vadim, Ori, and I will be outside after the session. If you have any questions for us, we're happy to chat in the hallway, and just a reminder to take the survey for this session. So thank you guys so much for being here, and have a great week at reInvent.